How you doing, everybody? Randy Richard in the shop. As you can see, this is part of my sticker board. There's these three cabinets here. I got tons more in the other cabinets and the other part of the shop. Thanks for everybody for sending me stuff. I have a project I'm going to be doing, and I needed a tool. Well, Evolution Tools contacted me, asking me if there was anything that it would interest me. So this is a tool I don't have in the shop, and I could use it in this project I'm going to do. Okay, phone's off. Let's go look at the tool. This is the Evomag42 drill, and we'll get it out of the box and show you about it, and we'll go over the specs for it. Here we go. It's out of the box. It all came all packaged very well, and it's in this nice injection molded type case. What do we got in here? We got the drill. We have some instructions. We'll pull that out. These are the handles, a coolant system. It's one of the nicer features there. This is what comes in the little tool tube, a safety strap, which you definitely want to use if you're anything other than a flat horizontal surface, upside down on a wall, or side of something. Definitely use a safety strap always. Comes with a chuck, 1/2-inch capacity chuck, and the arbor for the chuck, so it will fit up into the drill. It takes a 3/4 inch arbor, has 2 welding flats on it for the grub screws, and 4 Allen wrenches, and a fitting for the coolant system to attach to the drill. That actually flows down through the spindle, which is kind of cool. A guard. This guard attaches to the front, and the chip guard will fold out and swing out of the way. You may want a chip guard. The chips that come off can be very stringy, and they wrap around your cutters that you'll need to clear. But if they recommend using a guard. You'll see here and how it folds out open, so you can clean things out. That's the drill. This is what the bottom magnet looks like, right there. Give you an idea. Actually, pretty nice unit. Now, this is not variable speed. That's probably about the only downfall. It's not variable speed, but I can deal with that. It's 450 RPM is what it turns at. This one's a 120 volt model. This is the coolant system. It's gravity fed. It attaches on the side, right here, up here, like so, and will feed into this port here on the side of the motor, and then go through and down in the spindle. Has actually a fairly long cord, a little over 8 feet. On the back, right here, is the magnet control. Now, you cannot turn the motor on without having the magnet on. When the magnet is turned on, it provides about 50% of the strength. When the motor turns on, it increases the hold down strength another 50% to full strength. The 50% strength isn't more than enough to hold it on a vertical or upside down surface. There's a fuse here for it. It says it draws 10 amps max. So I don't know what the fuse rating is right this minute. This is the side for the handles, and we'll just screw those in. There we go. Now, this drill has a little bit of a different feature than I've seen on some. So it's a dovetail, for going up and down. It even has a scale here on the side. Now, that's up all the way. But you'll notice the pointer's like about here and about halfway on the scale. On the other side, on this side, there's a lock. Loosen the lock, and it can slide up on it. It's a double dovetail setup. That's fully up all the way, right there. So, if you have something large, you can still get this over something. So, table to just where the bait, where the chuck is. We'll call it the chuck. It's the spindle. It's just 11 3/4 inches, which is 300 millimeters. Now it has 135 millimeter stroke length, which is about 9 1/4 inches of actual stroke length on the hand wheel. But you can get something pretty good size under here and still be able to drill it. Put the chuck on, and then you have a drill in there, a jobber's length drill, which could be 4, 5, 6 inches even. You'll need that height, you know, for that. On this side is the lock. Now this is a left-hand screw. Just they even show you that here on the sticker, but they also mention that in the book. So left hand, so counterclockwise tightens it, clockwise loosens it. All right, this coolant system attaches here, and you put the screw in first, and then you slip this over the screw, so it comes off easily. And it's a shouldered screw, so you can just screw it in snug, and then you can just slip that on. That way it comes on and off easily. Has a valve, and then a tube that will attach here. And they provide a fitting that goes in here. Now that's one of those press fittings. Has an O-ring seal, so finger tight is good enough, and that just slips in there. Makes it easy to disconnect and take off. We'll slip the guard on. They provide 2 little thumb screws to hold it in place. When we get to drilling a hole, we'll probably take it off, but we'll give it a try. I also ordered a set of annular cutters. This set is 7/16 to 1 1/8 inches, and they're really good looking. They're very, very sharp. This set doesn't go to the maximum capacity of the unit. The drill can handle up to 1 5/8. One thing nice about their set now is that every one of them comes with you could call it a pilot pin, an ejector pin. These ones here, they all come with their own. They fit very, very nice in there. When you lower it down, it pushes up, right? So as you're drilling, you'll form a slug. Let me grab a bigger one. So your annular cutter will form a slug that will be up inside of there. Now this thing has coolant. So how does the coolant get to your bit? Well, these have a flat machined in the side of the pin. And when you push this down to the material, the coolant actually flows. It's gravity, but it will flow down around the pin and come out right where you're cutting. I think there's a spring up inside there that pushes on the pin, so it will eject the slug. But one thing great about having a centering pin on an annular cutter is it really helps stabilize it when you go to start. If you have a center punch mark and you put that pin in there, it really helps stabilize as it gets cutting. If you don't have something in there, they can be kind of chattery. So I have found I have another set of smaller ones I use working on aircraft all the time, and it has a spring-loaded centering pin also, and it's very helpful. And then with smaller ones, you can actually use a hand drill with. But having that pin, it's impossible to use a hand drill with. And the chuck here is 1.5 millimeter, 13 millimeter chuck, so 1/2 inch capacity. This is the arbor for it, 1/2 thread, and 3/4 shank to go into the spindle. That just threads in there. And then 2 flats for the set screws in the spindle. So that's 3/4. That's the same as all the that's the same amount as all these cutters. This is kind of a standard for this type of drill, this type of mount. You can see here that there's a set screw hole here and one at 90 degrees right there. I already backed those set screws out, so should be able to slip that up in there. So some quick specifications on the unit. 10 amps, 450 RPM. Yep, the cord length is 8 foot 2 inches. It weighs 26 pounds or 12 kilograms. Maximum capacity is 1 5/8 inch cutter, which is 42 millimeters. Max cutting depth, they say, is 2 inches, which is 50 millimeters. The shank is 3/4 inch. Twist drill capacity is 1/2 inch or 13 millimeters. Holding force of the magnet at full force is 2,860 pounds or 1,300 kilograms. Minimum thickness they want you to attach it to, plate thickness, is 3/8 of an inch or 10 millimeters. If you're on some thin sheet metals, you will not get that kind of holding capacity. Thicker is better in this case. So I'm going to turn this on right now. Now this is a nice flat, clean table, no paint on it. So there, it's on, and that's only 50%. They say, I can barely even move it. And if I turn it on, it goes to 100%. I was able to move it, but I was really trying. That's impressive. It really holds very tight. And it's not too loud, really. No more than a big hand drill. Maximum machine height is 25 3/4 inches. Minimum height is 16.5 inches. Width is 8 3/4 of an inch. Just under 90 decibels. Evolution tools there, or at evolutionsteel.com. They're a UK company. All the designers are in England and stuff. And yes, the unit is outsourced to China. So many tool makers, that's what they've done. They've outsourced everything, for the manufacture, but they're controlling, the design and all that somewhere else, just like here in the U.S. Other than that, I feel that it has nice lines. It looks well built. It feels solid. I didn't even have to adjust the gibs on the dovetails. Everything is solid. The instructions in here on how to adjust the dovetails if you need to. But I didn't even have to adjust them. Everything's tight. Everything's smooth. I'm impressed at how nice it moves and stuff. We just got to go drill something with it. Now the use of the safety strap right here. Safety strap. Now in this case I couldn't really use it, but right here. But you put it through the handle and then go around whatever you're doing. Hopefully, if you're upside down, it's going to be tough. But you want to get your safety strap, so you have to have something to secure it to. Old Milwaukee ones I've used before, and they came with a chain. In case you have a power failure, it comes flying off. If somebody kicks the plug out, it comes falling down. So that's the specs on it, and I showed you how to put it together. Pretty simple. We're talking pull it out of the box, and in less than 10 minutes you could have everything put together. They also sell coolant that they recommend for the drill, and this is a 1:8 ratio coolant, water soluble. So we'll be using their coolant on the drill. We'll mix up some of that. All right, we're over here on my small little fixture welding table. This is a 3" by 3" steel tubing. It's wall thickness of 3/16 of an inch. You can see where I did a couple test holes, and I put a couple more center punch marks in. We're going to drill it. This is the 3/4 shank with in the drill chuck. I have a 1/2 inch twist drill in here. Right up in there, we just line up one of them. They're 90 degrees apart. Now I'm going to loosen the lock on the dovetail here, and I'm I'm going to bring it all the way up on the handle and then loosen this and slide this up so I can reach over the workpiece. Lined up. Alright, we're going to put some, I'm going to use anchor lube on here since the coolant doesn't flow with the drill truck. Alright, that went through really quite easily. Like I said, the drill is sharp, but you know, the hole isn't necessarily the best looking hole as far as roundness goes, but it did go through. I did have to apply some pressure though. It wasn't like I didn't push it through. I did have to apply pressure, just moderate pressure, I would say. Now I'm going to change it. I'm going to put it in the same size as the 1/2 inch annular cutter. With the, it will have coolant. All right, we're going to slip this in there. Same alignment type of thing, right? Flats to the set screws. Just slip it all the way up. Now, when you push this in, there's spring tension. You can feel the spring, and that's for the pushing on the pin, the alignment pin. So push it all the way up there. Tighten against the flat. Now I'm going to bring this down. I'm going to lower this all the way down on the handle, loosen this, and bring this down so I know that I can reach through the material. Right there. I know I'll go through the material. That's probably a little even on the far side. There we go. I'll go through the material. And then I can bring it up, and I'm going to bring it over and align on the center punch mark. Right there. Turn on the magnet, and we're in. Now I'm going to use the coolant. I put coolant in the bottle, the reservoir, and I held it up high, and I opened the valve, and I bled the coolant. So I have coolant in the line. Now I'm going to turn this on, and you'll see it's running down, and it's kind of dripping out, right? We'll put this on here. Back on, just slips on, and we're ready to go. Now that took what, half the time or less. There was literally almost, I felt no back pressure from the cutter itself. I have, the gibs are a little snug and bit, so it won't fall down, but I only felt the tension on the gibs, which is negligible. It's a sharp cutter that went right through it like butter. So the force there, the amount of pressure I put on the handle was actually negligible. It went through so easy. And it looks, I'm going to show you the holes. It looks to be quite the round hole. Actually, it looks extremely good. We'll turn the piece around. But we're going to do a bigger hole too. All right, this is an 1 1/8 cutter, the largest one I have. It can do, I think I said, what, 1 5/8. And then you see what I mean about the chips are long and stringy. Now I don't have the guard on here, and in this case it'd be very difficult to use the guard because this is in the way. But in instances where you want to use it, you could. Now there's a slug in there. I'll take this out and I'll show you the slug. Let me turn the coolant off. The coolant works extremely well. Like I said, it took literally no force to push that through there. Alright, here's the cutter, and this is how the slug would look. Now this just literally fell out when I took the cutter out. and there's spring tension on it with the pin, so it just pushes it right out. So I would say that the coolant system works extremely well. The centering pin and ejector pin for the slug works very well. There's, like I said, there's a spring up there pushing on it. So this is the twist drill and the twist drill, 1/2 inch annular, both of those, and the 1 1/8 annular. Extremely nice finish on these holes. This is a quality of a boring bar. Actually, they're so nice, and they're round. These, you know, they're twist drill holes. They're not 100% round, and but these did an excellent job. Very impressed. Now, I was using the Evolution coolant here, and this is an 8-to-1 mix, so a gallon will last you a long time. Works just fine. Seems to be very good. Now, other things you could use other than a liquid coolant. Anchor lube, I used it with the twist drill. This is a water-based coolant for drilling and milling. You can thin it out with water and use it with a brush, or you can just squirt it right on. It sticks and works very good. I really like this with stainless. This stuff here, made by Hugin Slick Stick, also is a solid. It's in this tube here. Again, kind of a firm. It's soft. You can push on it, but you just run it up in the. You take your cutter and just run it in there like that, and boom, that's your lubricant, and it melts, and it works extremely well. For these type of cutters, this solid type lubricant works super good. I'm very happy with this. This is going to work great. I have a project right now to do, and we'll be getting on that here in a day or two. And I'm going to be using this drill right here for the holes I need to put in a steel plate. So thank you to Evolution for sending me this. This is very nice. This will work very well for me and work in my shop. Thank you guys for watching. There is a link below in the description to Evolution and their tools and this drill here. So please check that out, and if you're in looking for one, I can highly recommend this one. This is nice.